Very good afternoon. Today we are going to discuss a one of analytic functions. We are going to discuss about functions of analytic functions. First of all, what do you mean by analytic function? What do you mean by analytic function? Analytic function. What do you mean by analytic function? Any function that satisfies any function f of z that satisfies two conditions, that is ux equal to vy and uy equal to minus vx. Any function that satisfies ux equal to vy and uy equal to minus vx will be called as analytic functions. So now we are going to construct analytic functions. So for the construction of analytic functions, we are having three methods. The first method is called exact differential method. The first method is called exact differential method. Second method is substitution method. Second method is substitution method. Substitution method. Okay, and third method is MILNE, Millen-Thomson method. Millen-Thomson method. Millen-Thomson method. So first we are going to see exact differential method. First we are going to see exact differential. First method is exact differential method. Okay, exact differential method. Under this method we are going to construct f of z, that is analytic function. Okay, so actually what is f of z? F of z is u plus iv. F of z is u plus iv. So here there are two cases. That is, one case is when u is given. What will happen when u is given? Second case is when v is given. Okay, first case is when u is given, second case is when v is given. Suppose when u is given, we have to find v. Suppose when v is given, we have to find u. So how to find v? Then only we will have both u and v to complete this formula. So when u is given, what will be dv? What will be dv? dv equal to vx dx plus vy dy. Okay, when u is given, when v is given, what will be du? du equal to u x dx plus u y dy. Okay, so dv equal to vx dx plus vy dy, du equal to ux dx plus uy dy. But is it possible to find vx and vy since only u is given? Also see here, is it possible to find ux and uy when we are having only the value of v? So these two things here and these two things here are not possible to find directly. So we have to make use of the condition for analytic functions, ux equal to vy and uy equal to minus vx. Since we want dv, so I am changing all these v terms to u terms. So vx can be written as minus uy dx plus this vy can be written as ux dy. This ux can be written as vy. du equal to ux can be written as vy dx, then this uy can be written as minus vx dy. Now see, we are given only the value of u. From this u, you can find ux and uy. After that, substituting those values here and on integrating, you will get v. How? That is, integrating on both sides, you will get v equal to minus integral uy dx plus integral ux dy. In the same way, here integrating on both sides, you get u equal to integral vy dx minus integral vx dy. Okay, so from these two we can easily find both the values for here we are having u is given, so we are having another value v. In the second part, v is given and we are having another value u. So we can easily write u plus iv, that is f of z can be easily written in both the cases. Okay, f of z can be written on both the cases. So here also f of z equal to u plus iv. Here also f of z equal to u plus iv. So from these two we can find the function f of z. We can construct the function f of z. So you have to know one thing, what is V? Okay, what is V? Since U is harmonic function, means when U is harmonic, when U is harmonic function means V will be conjugate harmonic. V will be conjugate harmonic function. Conjugate harmonic function. Okay, so in the same way, when V is harmonic, means it is not true that U is its conjugate harmonic when V is given. Okay, so there are some properties. We shall discuss those properties later. Okay, we shall discuss those properties later. Okay, now we are going for substitution method. Now we are going for substitution method, which is the second method to construct the analytic functions. To construct the analytic functions. So second method is substitution method. Okay, second method is substitution method. Okay, so under this method we are going to see a formula. So we are going to see a formula, and the formula is given by f of z equal to, f of z is equal to 2 times of u. Okay, 2 times of u. This u is multiplied by 2, and after that we are going to have a z plus a and z minus a, z plus a and z minus a. This z plus a should be divided by 2, and this z minus a should be multiplied by minus I and divided by 2. Okay, so 2u into 1 by 2 of z plus a, comma minus I by 2 of z minus a. Then after that we are having a constant term minus u of a comma 0, minus u of a comma 0. So we are having minus u of a comma 0 minus I v of a comma 0. Okay, so this is a constant. So we can write this as f of z equal to 2u of 1 by 2 of z plus a comma minus I by 2 of z minus a. Then minus, this full term is constant, I can put minus c, or since it is constant I can write plus c also, because the whole term may be negative, this constant may be negative constant, so I can write plus c also, because it is arbitrary constant, it can take any value, so I can write it as plus c. Okay, now suppose if I take a equal to 0, okay, if I am taking a equal to 0, then what will happen means, taking a equal to 0, we get the function f of z which is analytic, the function f of z which is analytic at 0 plus I0. F of z which is analytic at z equal to 0 plus I0. Okay, 0 plus I0. Okay, so now what will we get? F of z equal to 2u of, here you will have z by 2 comma minus I z by 2, then we will have plus c constant, okay. So now we can, this is the required formula, okay. This is our f of z. Or sometimes it will be again rewritten as f of z equal to 2 times of u of z by 2 comma minus iz by 2 plus constant, okay. It can be written on either ways, okay. It can be written on either ways, okay. Okay, now we are going to see the third and important method. We are going to see the third and important method, okay. What is that? That is Milan-Thomson method. Milan-Thomson method, okay. That is Milan-Thomson method. So here also we are having two part, that is when u is given and second method is when v is given, okay. So what is f of z? F of z equal to u plus iv. We know that f of z equal to u plus iv. What is f dash of z? F dash of z equal to ux plus ivx. Here also f dash of z equal to ux plus ivx. But we are having the value of u alone as the known thing. Here we are having the value of v alone as the known thing. So we have to convert everything in terms of u here, and we have to convert everything in terms of v here. So our f dash of z will become ux. What will be the equivalent value of vx on analytic functions? Analytic function, we know that ux equal to vy, uy equal to minus vx. So this vx will be equal to minus uy, so minus I into uy. Here f dash of z equal to, what is ux? It is vy, okay, vy plus I into vx, okay. Now you have to know one thing, this ux will be the function of x comma y, and we write it as phi 1 of x comma y when u is given, and here uy of x comma y is nothing but phi 2 of x comma y. Okay, now when v is given, here we are having vy of x comma y equal to phi 1 of x comma y, and vx of x comma y equal to phi 2 of x comma y. Okay, so now we have to replace x by z and y by 0, and we will find f of z, that is f of z equal to integral phi 1 of z comma 0. Okay, here we are having minus I into uy, no, so we will have minus I into phi 2. Okay, integral phi 2 of z comma 0. Here we will have dz and dz plus a constant c, plus a constant c. In the same way here, f of z equal to integral phi 1 of z comma 0 dz plus, why? Because plus here we are having plus I, so plus I into integral phi 2 of z comma 0 dz plus c. Okay, where the internal constant c here is a complex constant, Okay, so here you have to do very simple things. When u is given means you have to find ux and uy. Okay, and after that substitute in this formula, but before that you have to know this ux is called phi 1 of x comma y, this uy is called phi 2 of x comma y. Replace x by z and y by 0 in either cases, and substituting in this formula you will get the value, or you will construct a function f of z. Okay, so f of z comes from this formula only. This ux is phi 1, this uy is phi 2, so here it is minus I, no, so you will have minus I. In the same way here you are having plus I, ux plus ivx, this vy plus ivx, this vy is phi 1, this vx is phi 2. Since there is plus in between, you will have plus I in between. Okay, plus I in between in the formula. So these are the formulas to find f of z when u or v is given. Okay, thank you for watching this video. This Miller's method is very important. Okay, kindly go through it. Thank you.